Hi everyone, it's Ben and Nick again from the Centre for Organic Electronics at the University of Newcastle, and we've changed location. We're now outside in a nice sunny spot, probably why we're squinting a little bit at the lens. Um, and we're out here so we can do a test of our solar cell in the environment, out in the sun. So Nick, do you want to tell us a little bit about the equipment that we have in front of us here?
Yeah, sure. So we've got our solar cell, obviously, from before. We've got a couple of multimeters here.
So what does a multimeter, Nick? What does it do?
Yeah, so that's a handheld device that allows us to measure voltage and current quite quickly. Yeah, and we've also got our light meter here, which will allow us to measure the intensity of the sun that we have at the moment.
Because obviously we do have a nice sunny day, but it is a little bit cloudy, so every now and again the intensity of the light we're getting is dipping down and then going back up. So this allows us to know how much sunlight is coming in. So this relates back to the equation we were talking about earlier, where the efficiency is related to the energy in and the energy out. So this allows us to get a measurement of the energy in. So Nick, what's this big box in front of me here?
Yeah, so this is going to form the load for our experiment. It's a decade box, so this allows us to dial up different resistances, and that's what will allow us to sweep through the voltage and the current of this solar cell and allow us to measure its IV curve.
So if we remember that IV curve that we were drawing back in the last video, we discussed that we change the voltage and measure the current, so this is going to allow us to do that, is that? Yeah. Okay. Fantastic. So, what's the first thing we need to do?
First thing is we'll get a feel for how much light we have around today.
Okay.
We'll do a bit of a measurement. Yeah, it's somewhere between about 210 and about 250 today with the clouds and everything. So that's about a quarter of what you would get on a bright sunny day in summer.
All right. So I'll mark that down. Okay, so that gives us an indication of how much energy we've got coming in.
Yep.
And now we're able to do the experiment to work out how much energy we've got coming out. So we've got this multimeter what is this one measuring?
We've got this one in parallel with our load, so that will measure voltage for us.
Okay.
And we've got this multimeter here in series, and it will measure our current for us.
Okay, fantastic. So, what resistance should we start with, do you think?
Yeah, so we've chosen a resistance here to start with of about 50 ohms, and that's giving us about 1 volt.
So we can see here on the decade box, it's 0, 0, this one's at 5, and that's 0. So this is the times 1 dial, the times 10, times 100, times 1,000. So 5 times 10 is 50 ohms. So it's a fairly straightforward box. It allows you to do lots of different resistances. So we'll start on 50 ohms.
Yep.
And we can take some measurements. So we'll put the resistance, 50 ohms.
Yep.
And what's the voltage there?
So we've got 1.05 volts, and we've
1.05.
got, if I'm not shading the solar cell, we've got about 21 milliamps.
So what happened there? You leaned over to measure that, and that went down quite a bit.
Yeah. So if you shade the solar cell, that's obviously going to affect the measurement. So make sure you don't do that.
So that's a real-time indication of energy in and energy out there. Okay, so that's our first measurement. And what we're doing here is we're going to change the resistance value, and that will move us through that IV curve that we drew in the last video. So as we change the resistance, it will change the voltage. So we're biasing the cell at a different point, and then we're able to measure the current. So what's the next resistance we should go to?
Let's look at 150.
150? Okay, so for 150, I'll leave this dial on 5, so that's 5 times 10 is 50. So I want 1 times 100 now. So I now have 150 ohms coming out of this box. Okay, so what's my voltage?
We're looking at about 2.6 volts now.
2.6, so that's jumped up quite a bit.
Yeah.
And what's our current?
And we're sitting at about 17 milliamps.
17 milliamps, so that's gone down a little bit. Okay. So we're getting closer to our open circuit voltage, aren't we? We're moving towards that as we increase the resistance.
Yeah.
Okay, what's the next one?
Let's look at 250.
250, okay. So we'll again move the 100 dial just to number 2. So we now have 250. And voltage?
We're looking at about 3.6 volts. And
3.6.
we've got about 14 milliamps.
14 milliamps, okay. So if you remember the IV curve, as you got closer to the open circuit voltage, the current that was available, that was being generated, got lower and lower, to the point where once we hit the open circuit voltage, the current is zero. There's no current flowing. So that's why we're seeing this current value. It started at 21, then 17, then 14. It's slowly going down. All right, so I'm going to guess we've done 50, 150, 250.
Yeah.
You reckon 350?
Yeah, sounds like a good place
we'll
to
do that
go.
one. Yeah. 350. Okay. What are we at now?
Yep, so we're at 4 volts, and we're at about 11.5 milliamps.
11.5 milliamps. Okay.
It's also a good idea to occasionally check on the sun and see if that's staying about the same or if it's gone down a bit. We've gone down about to about 175 watts per meter squared in the time that we've been talking to you. So there's also been a little bit of a change in our input energy as we've been doing these measurements.
So I've just made a note of that here. So that allows us to, when we're looking at this data, when we plot it, we might get strange jumps, and you might think, oh, there's been a problem with the measurement. In fact, there hasn't been. It's just the energy level coming in has changed. So obviously the energy level coming out has changed. Okay, so we've got most of our measurements. We're just going to focus on a couple of key points that are related to the IV curve that we've been discussing, and that's the open circuit voltage and the short circuit current. So right now we've got our decade box set on 5,010 ohms, so we're over on the 5,000 dial here, we've got 5, and on the 10 dial we're at 1, so 5,010 ohms. So that's a much higher resistance than previously, and what that is going to do is push us into the open circuit voltage location. So what voltage are we getting there?
Yeah, we're at 7 volts, and we've got not very much current, like about 1 milliamp or something.
1
like this.
milliamp.
So
So
it's
that's
very low.
effectively zero.
Yeah.
So we're getting very, very little current flowing at that point. And we've got 7 volts, which is going to be pretty much the maximum voltage we'll get out of the cell. Now, conversely, if we go to the short circuit location, which I think if I dial this down from 5,000 to 0, and we're sitting at 10 ohms now on our decade box, that's going to take us right to the other end of the IV curve, where we're going to be crossing the axis, and so we're getting the maximum current that we can get out of the cell and pretty much the lowest voltage. So what do we got there?
Yeah, so we're at about 0.2 of a volt now, and we're at about 24 milliamps.
24 milliamps.
So about the highest current we've seen and the lowest voltage we've seen.
So there we've identified the 2 points that are really of key interest to us, the short circuit and the open circuit voltage. And with the other data, we're now able to generate that IV curve and plot it up and see what the curve looks like. Now, normally, we don't come and sit outside and do these measurements every day for the cells that we're making. We work inside the laboratory. And so now we're going to cut over to the solar cell testing kit that we have in our lab and show you a little bit of how we do that test in there. Okay, so we're back inside now in one of our testing laboratories, and we can see Nick is moving up to the plate loading facility we have here. So our solar cell is going to be put into a cartridge, and this allows us to do the testing in the solar simulator because our cells are quite flimsy. It's very hard to use them otherwise. So it's now in a nice plastic cartridge, and he's walking over to the testing tool, opening the door there, and he's going to load the cartridge in. So this is a pin bed device which we put a whole bunch of pins onto the solar cell and allows us to do the measurements that we want to do. So once that's loaded, he gets on the computer and he will get the pin bed to deploy, which it will come down onto the solar cell. Okay, so the cartridge with the solar cell is loaded now, and so Nick can start doing his testing. So he's got an IV curve running, so the lamp is on and it's taking the measurements the same as we did outside and generating the IV curve in exactly the same way as we did. It's just an automated process. And once we've done that, that data will be stored in our database along with the thousands of other tests we do, which allow us to do this research.